Right.
Sir,
Yes.
yeah, sir, actually, before you begin, I just want to let you know. So, actually, the classes will be only on the weekdays, right? Because weekends, actually, I'm little occupied. So, Saturday, Sunday, we will have, or it is just weekdays?
Uh, no, we don't. Will not have classes on Saturday, Sunday.
Okay, okay. Thank you, sir.
Okay. Because students are having problem, so it's okay. So we are having 1.18.1 version. That is basic thing. Mhm. Okay. So in the NumPy basics, the very particular thing in the NumPy basics combine of the data types, the array creation, input and output with NumPy, broadcasting, byte swapping, structured arrays, writing some custom arrays. Okay. So first we will be going through the data types. Okay. How many data types are there in the NumPy? Hmm? So there are boolean, there are bytes, there are unassigned integers, there are assigned integers, there are single, that is float, there are doubles, there are complex, there are I think float we have said, complex we have said. Yeah, so like these are all the data types. Okay, mostly you will be getting the float of 64 or 32 there. Okay, so NumPy numerical types are the instances. Okay, you are getting of a numerical Python, and the numbers you are getting there will be, or anything what you get inside the array will be having some data types, and these data types can be used as functions to convert Python numbers to any scalars or any sequence of numbers. Okay, so what are exactly about the data types? So we'll see. These are the structured arrays. Okay. So let's say this is X, which is a NumPy array, and this is very clear. If I write 1, 2, 3, kind of, and I see my X, that is an array of 1, 2, 3. Okay. But like talking with the data types, if I say this is np dot float of 32 bits of, let's say, 4.6. Okay, so this is 4.6, or if it is 4, if it is 4, 4.0, like conversions I'm saying about. Okay, what we do in the, like, for integer of something or float of something, right? We can write this similarly to this. Otherwise, what you can use is you can define d type is equals to something, something that's like float or anything. So you can write it as np dot an array of, let's say, 1, 2, 3. Now here, in the case of d type, you can write np dot float of 32 bits and whatever you want. Otherwise, you can just write f, that means float, and by default it is a float of 32 bits. Okay, so you can use d type, or you can even write it this. Now if you, like if you are having any array, right, in some different data type, so to convert the type of an array we use dot s type. It is like if you're having an array, let's say x is an array, right, that is 1, 2, 3. So to convert an array in any other type, we are going to use s type. S type. Okay, and inside the parenthesis, then you should mention what you want to convert. Let's say you want to convert in the float, so it will be done inside a float. Okay, cool. So similarly, like if you want a Unicode or a kind of that, you can just write it there, np.float or complex or np.complex, booleans or integers. Hmm? And if you are having array and you want to check it, the data type, that is easy, right? That is data type dot name. and you will be getting the data type, right? So this is the previous one, that is we haven't assigned the value of x as to the float of here. We have just written this, if we write x dot as type of float, then we are going to get this, right? But we haven't assigned it in the x, so x is having still the integer. Okay, fine, cool. Now, so data type also contain information about the type, such as like you can say bit width or byte orders. All right. So the data type can also be used, you can say, indirectly to query properties of the type, or like where just where these things will be an integer case. Okay. So let's say that you are writing an np dot integer of d type. Hmm? So np dot, okay, something wrong I have written. Data type of integer. By default, what it is? Integer of 64 bit. Okay, with machines, with my machine, it is 64, integer of 64 bit, right? So if we say that any data type, that if I write that np, just make it smaller. So if I write that np is sub data type, right? How we write subsets, sub data type of, so what I'm going to check, np data type of integer. So I'm checking whether this is a subtype of integer. So that is true. Okay. Similarly, if you have having a float, you are checking it for a float, then obviously this is not a float. False. Okay, right, floating. That is false. Okay. So this checking of the subtypes you can say on, right? Similarly, we are having the scalars and all, right? Like, so what properly if we say, then what are the common data types in the NumPy is integer, float, complex, string and unicodes, right? Now what is like if we want to write up something in the power, hmm, in the something raised to the power something else, like 100 to the power 10 or 10 to the power 10, 10 square, in that case. So how do we normally write up the things 45 or 5 to the power 2, and we get the values? Here we can use np power. Okay, write the number to the base whatever you want and then the power. Clear? And even if you write the data type you want here is a float, you would get 25.0. So accordingly, what you write, you'll be getting your answers. Okay, fine, good. Now the behavior of NumPy and the Python integers differs significantly from integers and all, right? So there are various functions like numpy.info. So I think I have given you the introduction of how you can go with the info, what it does exactly. Okay. So numpy provides you numpy info, double I info. I say it I info, right? So numpy provide you I info, and also it provides you f info to verify the minimum and maximum values of numpy integer and floating values, right? So I info and f info will be giving you the like maximum and the minimum values what numpy integer can hold. Hmm? So if I write np that info, right? That is I info, what I'm saying. Okay, so numpy dot I info of integer. So it will give, this will return the bounds of the default integer of the system. Okay, so it bounds all the default integer of the system. So integer of 64 by default will be taking maximum, you can say the values to be this and the minimum to be this. Okay. Similarly, you can just give it for this integer of 32 II info of integer of 32 bits. Not defined. Okay, just write it NP, and that's it, right? So the values differs from the integers to integers, even with the bits. Okay. All right. So this is like the basic data types we are having, and how do you convert other things. All right. Cool. I'm moving this up. Okay. And understanding of the 5 general mechanisms in the arrays. That is conversions of Python structures or list or tuples, you can say, or intrinsic NumPy creations like arrange ones or zeros. Okay. So if we say that there is a list, and these things are clear to you, so I'm not going to discuss these all again. If you want to make an array of D, this is clear to you, right? So we are not going to discuss about this. And also we have discussed about the ones, the zeros and all, right? So if we just write np dot 0, so what it does, it will create an array filled with the zeros with all the specified shape. So and the default type of the 0 is always float of 64. If you define that np dot zeros of, like, let's say 25, and if I'm reshaping this in 5 cross 5, I'll be getting something like this. If you write in some ranges, and then you get some respective results. If you write np dot zeros of let's say 2 by 3, spelling it. So you get accordingly the results, how you write up the things, the reshapes and all. Okay. Next. So zeros and ones, I think this is very clear to you. I'm just writing this, okay, not repeating this off. And then also we saw something as dot I, that was an identity matrix of whatever you write. Let's say write for 3, so identity matrix diagonally 1 you'll be getting up. So ones will be creating an array filled with 1 values, and that too identical to the zeros exactly, right? Next week, I think we also saw the linspace. That linspace will create a specified number of elements or samples, you can say, and these samples of the numbers are spaced equally between the specified beginning and end values. Like if we say that np dot linspace of 2 to 4, so by default there are always some of the say samples to be 50, right? But if we define, what if we just define up this numbers, then let's say it is going to be 5 or the 6, so in that case it will be there. And if you want to return the steppings, you can write red step to be true and you'll be getting it there. Okay, so this is an advantage for creation of a function, or like an arithmetic progression or something, like if you want. So there is a function called as indices. Okay, so this indices will create a set of arrays, you can say one per dimension, with each representing a variation in that dimension. That is, if you get the more information for this, it will be, if I write np dot info of So you see, okay, quite big. Yeah. So this returns an array representing the indices of a grid. So let's see just the example over here. So if it is writing that indices of 2 to 3 and then getting the shapes, so you're getting 2 rows, 3 columns, and the numbers, right? So some grid numbers will be there, kind of. Okay. Now this is very particular useful for evaluating functions, or you can say for when you write multiple dimensions on a regular grid. So we use these things to wind up with all. Okay. Next, we are going to look over for the conversions, or you can say intrinsic numpy characteristics. Okay. So the mathematic parts of like the sine graph and cos graph and tan and all of those things, right? That is being calculated just simply by writing dot sine, dot cos, and dot tan, and simply you'll be getting up the things. Okay. So how to go with the input and output with NumPy when we say that we are just importing some data and generating some inputs and outputs with this. So like generating from the text and using the delimiter functions and all. Okay. So that we will be discussing later onwards, right? For now, let's just focus on different things. So we made an X, right? That is like 1, 2, 3, and 4, 5, 6. And we found the shape to be it's 2 by 3. Let's take a copy. And now y is also the same thing as x. Now in the previous session we saw that if we write something, did we saw the concatenate? I think we saw it. So if I write the concatenate of x and y, so by default, what I said previously also, that by default you will be getting your things in the column wise, the vertical, right? By default you get things like this. Mm-hmm.
Sir,
Yeah.
please explain that again. Shape one, that x dot shape. I don't understand.
See, shape is like it is saying you are having 2 rows and 3 columns. If you see your x, or if you see your y even, so that is a copy of x. So
Okay,
see,
okay.
just
Get it, sir.
2 rows,
Get
3
it.
rows. Okay. So did we saw this concatenate previously? I think so, right? So by default you get up like this, right? And you have options even, like if you define the axis, which is the grid we are having, so axis equals to 1. So in that case, you'll be getting the things in row wise, you can say. Or you say you'll be getting just a combination of the arrays elements, like in the first one with the first, second with the second. So element wise joining of all the arrays, what you define inside the concatenate in the row, that is row wise, when you define it as equals to 1. But when if it is equals to 0, again it is going to be the same as what is the default method. So to avoid this, right, instead of writing up with the x's and all, what there we do is just write np dot h stack. Then we write x comma y, and that is horizontal stacking. Or you write np dot v stack for a vertical stack. So you get a vertical stacking out. Similarly, if you write d stack, you get things in the depth, right? That will be defined in the equal depths. Okay. So in this case, you'll be getting things in the very equal depths of this, or you say in the equal heights. Okay. Fine. Now,
So, can you please repeat the V stack and D stack? I mean, it is a little confusing. V stack and D stack.
V stack
What is
is
happening in this?
V stack is vertical stacking. Vertical stacking, or you can say even the same thing what you get in the excess of 0. So instead of not writing as a concatenate of this excess of 0, we are just writing a vertical stacking. Like it means column wise joining, and you are getting other things. Like the first array was 1, 2, 3, 4, 5, 6, and then we joined the another array 1, 2, 3, 4, 5, 6. Okay.
Okay.
That is a like vertical stacking we are getting. And the D stack, if you just see up there, what you can see this 1, 2, 3, this first one, and the first of the second one. That is the first of first one, and the first of second one. So you're getting all those things in the equal heights, or you can say as in two equal arrays, two different arrays you are seeing. See, this is one array, and this is the another array, and in some different equal heights and widths. Okay, like the depths I'm talking about. If you see the shapes, like 2 by 3, this is even, and this is also 2 by 3. So the two shapes will be same, even if we separate it. Okay. Alright. Moving next. So we had a proper thing for this numpy actually, and let me show you. There we have something called as data science. How that is this, and there. No, I think in the Python there is Python cheat sheets for the data science. I hope it would be. Orange is for numpy, green is for numpy, blue is for numpy. Where there's orange, yeah. So if you could see up the things here, that is the very first thing, we'll be discussing it all of them. Okay, don't worry. Every functions what you are seeing here will be discussed. Now, so a numpy array something looks like this 1, 2, 3. And then the 2D array is like excess of 0 and excess of 1, which are having rows in the columns, where the 0 you are getting up is all about your columns, and the 1 is for the rows you are getting. Okay. And then we have 3D, and we also saw this, right? So we define some 3 arrays like this. If it is one array, we define like this. Many times you could see in the place of square bracket, you could see some tuples to be written up there, right? So it can also be there that tuples are written in place of square brackets. That means same, okay? It means that still you are making up the numpy array only, okay? Fine. And next we have like the placeholders. So we'll be going up with 1. So zeros we have completed, ones we have completed, arrange also we have done. We'll see it once again, right? Linspace we have seen, I we have seen, random we have seen. What is being left? That is full and the empty. Okay, so we'll go with
So can this be shared with us to go through?
what?
Can this be shared with us, this cheat sheet?
Yeah, sure. You'll be getting
Thank you.
this numpy, you'll be getting scipy, pandas, scikit-learn, matplotlib, cbones, everything. A lot of things are there. Okay, where was I? Even also, I'll be sharing a book with you orally for the data science. It is in that drive actually. Okay. So zeros, I think it is clear that it creates an array of the zeros. Once it creates an array of 1 with specified your length and all what you write. Okay, and I think that is also clear. Right. Moving next. Uh, Next comes the arrange. Arrange is like making an array of evenly spaced values, spacing the step values again. In the length space, you get the evenly spaced values, right? The number of samples you want here, and in the above one, you can see you get only the stepping values, not the number of samples there. Just a stepping, you'll be getting up the answers. What about the full? It creates a constant array. Let's just see what this constant array means. So np dot full, and what it is written up there, a full of 2 cross 2 of 7. Is this right? And let's see what comes. 2 cross 2 of 7. So what you can see, 2 rows and 2 columns, total filled with only the 7th number. All right. So if you're making an array and you want only one number to there, like we write for ones, right? If we write it like ones of 2 by 2, what happens? Everything you'll be getting of 1. And even if you write that you want the data type to be np dot integer, so you get a things like that. Okay, 1 second. Students are actually previous batch students are giving a test. They had a problem. 1 minute. That is not working. Okay. Can I profile? Okay. What questions? Okay, unsupported cell types. Alright, fine. So np of 1 was this, right? So here we can see, like, if we write for the 0, we'll be getting zeros. If we write for ones, we'll be getting for ones. If we write at as inf, that is for an infinite value. Okay, and what is an infinite value specifically? So infinite, you will see that if you write an np dot inf, that is an infinity or infinite value. So similarly, if we want like one particular number to let's say to full it with full an array only with one number, then we will be going to write np dot full, and then just write the shape you want and just write the number. Right? Get it? Okay. Next is np dot empty of 3 by 2, that creates an empty array. Okay, fine. So this is np dot empty of, it's saying to be, let's just first see for 2 by 2 what it says. One. So it takes,
Sir?
Yeah.
So can you please repeat the np.inf part?
Sure. So that is an infinite, like if you are giving any particular, if you're doing any mathematical calculation and you want some range or kind of like if we write an integral of something, like we give lower limit and upper limit, and if it is infinite, we can use in that case infinite. So that gives an infinite value. So like if you can get the more info here, so converts a string to a number and floating point, and if it does, so it just takes a range of kind of thing. Like let's just say, let me say you right. I'm saying for the situation, like if you are having, okay, so let's just think of that you're having a situation here, and you have been asked to make an integral of this from 0 to infinite. Like we are giving some infinite sign, right? So in that case, when you're solving in the numpy, we could properly write it as np dot infinite. So that could work there, right? For the nan, we are having np dot nan, nan. So that is nan, not a number. That is nothing, right? No spacing is there. Like we'll be seeing up in the pandas when we work that what is and nan values, right? When we deal with the mathematics, we find infinites. So we write it like this. Okay, that is the use of it. We'll be doing it when we'll be solving some problems. You'll be getting it more clear. Okay.
Okay, sir.
All right. So where was I? I think I was in the empty. Yeah. So okay, fine. So what you can see, if you are creating an empty of 2 cross 2, even if you create an empty of 5 cross 5, what you can see that it randomly selects some numbers and will just make array of that. Okay, right? Or like I would have to see it for a proper definition. Mm, hmm. Where it is? So empty. Yeah, so it returns an empty array with a shape and type of an input what you write, but some uninitialized. Yeah, that I was saying, that takes some array that is exactly uninitialized. That is, you don't define out the entries. You don't define what to be specified in an empty one. So that returns a new array with a given shape what you write, and the type also. Like if you define an integer or float, it will be coming exactly of that type, but without initializing entry. That is, some random things will be coming up there. So you don't define up the things, and it would be coming any random thing, whatever you define. See, we are even getting some nan values. We are even getting some exponential values. Okay, that is empty working. Okay, fine. Moving up. So this is like you can see up here also. To the two and for an integer if you want. Similarly, the things you get. So these are the initial placeholders. Moving up with the saving things on a disk, right? If you have made an array, you want to save this, load an array, you write it like that, saving and loading files. Moving up with the data, where it is. So data types we haven't discussed, right? That there are some kind of, 1 minute. What is this code? Oh God, where is this? Okay. So we have seen about the integer. Okay, let me. Yeah. Okay, fine. So integer of 64. So signed 64-bit types, float, complex Boolean Unicodes. Okay. Moving up next is about the arithmetic operations. So in the previous session we have done this multiplication, division, and all, right? And also I have seen you that how to multiply the thing with writing up with add, divide, multiply, exponent. Even you can write mul to get at the things. Okay. So exponentiation, square root, the sign, log, cos, and the dot product. And this you might got in the examination also, the dot product. So what are those things? Like if I write an exponentiation of 5. So like this. In this case, if I write an exponentiation of 5, that is e to the power of 5. And okay, this is not a module of numpy. Okay, don't go with this. You'll be confused up with this all. Okay, let me just delete this. Otherwise, you'll be confused up, right? How it is working. For those who will see directly the videos, will be just confused. Okay. So exponential values comes like this. Okay, 5. And even you can find up the square roots, sqrt, of any number, and you get the square roots definable. Next we have comparisons, where like if you have an array and you gives equals to some other array, so you don't get any values as to be a true or as to be the false. You get the values as an comparison based on the element wise. Like if I say that this is my A and this is going to be 1, 2, 3 and 4, 5, 6. Okay, and this is my B. Now this step is very important, guys. Okay, if it is 3, 4, 5, and if this is I'm saying as 4, 6, and 7. Okay. Now these are actually important steps. Now if I say A is equals to B, now here you're getting it as like a discrete value, you can say, right? That is, it is false. Okay, that is false. But if you want to compare it like an element wise, if you see up your A, that is a just a kind of a list I'm having right now. Okay, so this is a list and we have compared and we have got the discrete value. But in case if I write the C, which is equals to np dot an array of A, this is A, alright, and this is D, which is going to be the array of B. And now if we compare C equals to D, we'll be getting up some discrete values with an element wise comparison. That is, I'm giving a difference between when you compare up in the list and when you compare up with the array. So here I'm getting one true result in the place of the second one, and the first element of the second row, you can say. So the first element of the second row is 4, and yes, we can see that the second row element, first one, is correct. That is 4 and 4. Okay. Now, did I say to you the function of np dot where? Did we saw that np dot where? I don't remember if I have said. Okay, fine. So with np dot where we can easily find out like how many occurrence of something are there, or like if you want to count up something, you want to find the index number basically. So if I want to see that when we compare C equals to D, right, where the values are coming as to be the true, like this. Okay, so this to be have within some different array particularly. So you can write in the F where you can find the array to be the true, and here it is saying that in the place of 1 and 0, that is in the first row the 0th element, that is in the first row the first element, or you can say this as the second row the first element. If you write that of the F, the first row of the 0th element will be your true. That is, I can see that if f of 1 of 0, I can see true. Similarly, if I write f of 1 of 1 of 1 will be giving me false. But 1 of 0 is true. Now what is 1 of 0? If I see 1 of A and also the B of 1 of 1. What is this? List indices must be, oh sorry, this is C and D, right? So, oh sorry, this is 1, 0. What I'm doing, yeah. So this is 4 and 4. Okay, so got it the point, like how we compare the element, like how we compare the equalities by element wise. Any doubts in between these things? Anyone is having any doubt? Moving up next. So if you have, you can ask them there. Similarly, you are having less than, greater than, and all equals, array equals. If you just want to operate an array-wise comparison, you can use array underscore of equals of the two arrays, and you could get at the things. And there, let's say, if this array is having, where it is, if this array is having 1, 2, 3, 4, 5, 6, and you want to see like inside that, see where the element are greater than 2. So you can see the like the places where getting true results at that in the first row, that is in the C of 0 of 2, which is 3, okay, and rest of all the C of 1 is going to be the correct one. That is the C of, like, if I write it as, okay, sorry, why to make it so 2. So this is these are the elements, even the index number you can find if you write np dot where here in place of this. If you write np dot where the C is going to be greater than the 2. So this could give you all the occurrence of the indices, that is the 0 of 2, the 1 of 0, the 1 of 1, and the 1 of 2. Those are the places. Okay. So how will you get it exactly? Just if you write up the things, because we will be seeing up one very common problem. Okay. So I'm saying it to you right now. So let's say this is G, and writing for I in the length, or phi I in the np dot a range of, let's say, for 100, or even let's say for 1000, 10,000. So a range of 10,000 np dot random dot randint okay. So some sort of numbers I have taken. 1 minute. Sorry. So np dot random dot randint, and this will be equals to h. Let's take j equals to this. SDR of h. Let's run this. Done. And let's say that G is going to be an array of G itself. So what is the length of this G, or what is the size of this G? 10,000. What is G is containing exactly? What are the first 10 objects of G? Okay, this is quite big. So first 5. So what is, you can see up there, it is 5 Google codes. In the previous in the previous session, we just saw that how to make one Google code, right? And now we have made around some like 10,000 codes within some seconds, microseconds exactly. So we can see some codes, 5 codes. Similarly, if I just print over the total G, we'll be getting around some codes starting with 4063937 and such a big number. Okay. So 10,000 numbers are there. There is 10,000 codes are there. So from here, can we see that how many codes? Let's say if I write, if I write just y equals to a list, okay, and I just say that for I in range of some 50, okay, I want to say np dot random dot random. So np dot random dot random from 1 to 10. So this is equals to, let's say, j. No, let it be equals to k, l, and I'm saying that y dot append l, and then y is being equals to and array of l. Sorry, y. What is pn? So if you see a y, it will be some 50 numbers, right? An array of 50 numbers. But what can you see here? That the numbers are also repeated, right? 9, 9, 9, many times. So what are the unique numbers? Unique numbers in the sense, like, what are the exact identical, like you can say even the same non-identical, sorry, so non-identical numbers of the y. So only there are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So till 9 only you are having the elements inside your y, okay? But we are getting 50 numbers, right? So that obviously means that there are some duplications. If you are having 9 and total numbers is 50, then it means that there are some of the duplications. That how many duplications for how many letters, like how many numbers are having duplicate values of that, how many occurrence. We can write xy, let's say qwe is equals to np dot unique, and this is the very beginning thing what we write, np dot unique of y, and then you can write that return the count is equals to true, and the return of index is also going to be the true. Now what are these two things? This return of count is particularly given because, right, if I get some unique numbers, then if I'm getting 50 numbers, why I'm trying to find the unique? Because there are some unique things, right? So unique only are there for the 10, and the rest are having 50 values. So like we just want to see that which number is repeated for how many times. So that will be getting up with the return counts, and if a number is like repeated for whatever the times it is, like 1, 2, 3, 4, 5, it will be coming inside the count, and this returned index will be giving the count of those index, right? So if you can see it better in the program, let's just take it. So what is Q? That is a unique thing. Now what is W? That is 6, 8, 27, 3, 10, 1, 2, 0, 11. So the unique numbers are getting its occurrence, right? Occurrence means that if I write a Q of 6, it states that this is 7. So Q, what is Q? This is 1, 2, 3, 4, 5, 6. Right? So Q of 6 is 7. Starting from 0, this is 7. So what you can see, like in the y, what if it is there? Right? The sorting, np dot sort, if I write np dot sort of this y, what you can find that there 1 for 1, 2, 3, 4 times, 2 for 1, 2, 3, 4, 6 times, 3 for sometimes, 4 for many times, and like this there are the things, right? What about this? I think W is something different, right? So what about E? Yeah, okay. So you are getting up the occurrence of all the numbers according to this Q. So 1 is for 4 times, 2 is for 6 times, 3 is for 3 times, 4 is for 6 times, 5 for 7 times, 6 for 8 times, 7 for 4 times, and so does 9 for 5 times. Okay? So I've got, and where are those things exactly starting up? So for 1 it is 4 times, and it is the 6th. The index we are getting up there, that is 6. Okay, fine. Then you're getting 2 for the 6 times, and you're getting it as 8. So if we just see of the things here, right, that is 8. Fine. So similar to this, if we just look up in the G, so how many? First we'll see the length of this G, and then we'll see the length of the unique of this G. So see, there are some 10,000 actual numbers what I have defined, and I'm getting 9,737 9 numbers to be the non-identical, right? So if I say my ASD, and I say it to be np dot unique of this A, and let's say return index to be true, and return the counts to be true, and if I see my A, okay, what is this? This is for the G. So I could see some numbers, that is 9739 exactly. So what is this S? So this S is giving you the index numbers. Okay, it is not like a code is being printed for 2135 times. Okay, this is the index number. Like if you see the A of 2135, so this is this code. So if I just copy this, and if I find this inside this G, if I just see that in G where this is equals, where I'm getting this code, so you will get some locations directly, right? You'll be getting a location basically, right? Where you can just write np dot where this is equals to this. So I'm getting at 4249, right? That is G of 4249. It's going to give me the exact code, but why it is have been printed here? We'll go through all these questions. Okay. Now let's say we have got S, the index, right? What about this D, giving the counts? So counts like starting from 1, 1, 1 and all. So how could we know that what are there inside of the counts? So you can write that np dot the unique of D. So there are also the numbers which are greater than 1. So what we'll do is np dot where the D value is greater than 1. So all these are the locations where these D value are greater than 1. That means that these are the index positions in the D. Okay, these are the index positions of the D where there are duplications. So if we just randomly select 1, so if we just see what is the D of 5, this means 2. Okay, if D of 5 is this, then what is the S of 5? This means 1921. So what is the G of 1921? This is this code. So So we'll copy this and we'll see np dot where in the G this is equals to this. So it says it is there in the two states or in the two positions in 1921 and 7620. So if we see the G of 1921 and also if we see the G of 7620, we'll find both the same codes. So this is exactly only 10,000 codes over here. So when you deal with the big data and like when you deal with a good number of data, you find it to be 1 millions. In that case, how would you work? So these are the techniques of like finding up the codes, right? If you say that you haven't given some quite good number of data, let it be only of 10,000 even, right? And you've been asked to work in the Excel to find that how many common elements are there, how many uncommon elements are there, and how to deal up with thing. It might take some time, right? Here it is very easy. I'll show you one thing more, right? So these are all the list of the numbers which are being duplicated, the index numbers which are being duplicated. So what we can do is we can make one list, let it be L1, and that will be this, a list. Okay, this is going to be this list. Now let's make a list 2, which is going to be the list 2 of this S. Okay, so list 2 of S. Now make this as this. Now what we'll write for I in the L1. So for I in the L1, what we'll say L2 S dot append, and what is to be appended, right guys? That is, if it is 5, what we did, that S of 5. Okay, so here what we are going to do is S of I. So what is L2S? This is a list of all the numbers or the index positions. Okay, all the index positions. All right, so just make it as now GC, or let's say the codes we are going to print, like what are the codes which are common. So this is also a list, and now we can write for I in this L2S. Now what to be done? GC dot append. What is being appended? Right? It's NP dot where you are finding in the G, you are finding this I. Okay, 1 minute. I think we have to find for this also G of I, and then we'll be going in that. Okay, so G of I. So G index will be going for find, right? So G of I you have to find. So this is G of I. GC is not defined, GI is defined, and that is fine. So what is GI? This is 1. These are the Google codes which has been repeated, and you can see up there the things, right? These are the Google codes which has been repeated up. Okay, so there you can see some 2 or like the codes which has been repeated. Now it could be GC, and it can be a list, and for I in this GI we could, in the GC we could append all the occurrence of this GI, right? There we can decide that NP dot where the G is equals to I, and this GC is going to give you all the like it is going to give you all the numbers or all the codes, like for the one particular, like if you're also print even that the GC, if you write GC of 0 of 0, you'll be getting it as that this is a particular array, and even if you write the 0, you'll be getting 1921. Similarly, if you write GC of 0 of 0 of 1, you'll be getting the first two numbers, and then you can find out the things, right? So I believe that it is clear to you, right? So this is a data of like 10,000 Google codes, right? So if we just write it as that NP, that whatever the G is there, I'm reshaping this as 100 or 1000 cross 10. So now if I say that you all have deal with the pandas also, if I say that this is going to be a data frame of the data which is going to equal as G. So you could see properly whole data. If I say this is going to be equals to D, so D dot head is going to give you all the codes generated there, right? The data sheet of this. So what you can say, let's say GHTML is going to be D2 underscore of HTML, and if I write this as gcodes.html, or if I write G underscore of CSV and equals to D dot 2 underscore of CSV, and this is as gcodes.csv. That is, I want to convert these files in some formats. Now these will be stored inside my folders, so I can even download of these things. Enter, this is download. So if I open this, and if I see this codes, so what you can see is an HTML sheet of all the Google codes we generated, and this is all about the 1000 codes. If you can see your Excel, so you've converted your codes in the CSV format just with use of some couple of lines, right? And if you've been asked to find up to sort up using this all like sort A to Z or like kind of things, you could probably do it, and it will take some times because everyone is not good very at Excel, performing at Excel, but everyone can be good at performing with the Python, right? Because it's easy as compared to anything. All right, guys. So understood anything, or it was just like a bouncer? Got the points and the facts? Hmm? Let me stop this.